Hey everyone, today we're going to be talking about multiplying rational expressions. So, remember that rational expressions are similar to fractions, where we're going to see another way in which they're similar to fractions, and that is when we're multiplying them. So let's say we have the rational expression 10x cubed y squared over 3x to the power of 4 y to the power of 3, and we're multiplying that by another rational expression, 21x y squared over 5x squared y. So in order to multiply these two rational expressions, what we're going to want to do is we're going to want to notice, first of all, that both of these are fully factored. You cannot factor either of these rational expressions at all, right? Neither the numerator or the denominator. They're already fully factored. So that's what we're going to start with. We're going to start with multiplying rational expressions that are basically already fully factored for you, and then the next question I'm going to do with you is where you have to factor yourself. So when they're already fully factored, all that you need to do, okay, is you are going to start by basically multiplying the two coefficients from the numerators and multiplying the two coefficients from the denominators, kind of like when you're doing when you're multiplying when you're multiplying fractions, rather, you would just multiply the tops and then multiply the bottoms. We're going to kind of do the same thing here. So we start by multiplying the two coefficients in the numerator, right? Multiplying the two coefficients in the denominator, and then we're going to multiply the variables, right? So when we're multiplying the coefficients up top, we get 10 times 21. When we multiply the variables, we get x to the power of 3 times x, which gives us x to the power of 4. Then we do y to the power of 2 times y to the power of 2 up top, which gives us y to the power of 4. And on the bottom, we get 3 times 5 from the coefficients. And for the variables, we get x to the power of 4 times x to the power of 2, which gives us x to the power of 6. And then y to the power of 3 times y, which gives us y to the power of 4. Okay, so at this point, you're going to notice that we have some stuff that we can kind of cancel out. We've got multiple x's in the top and the bottom. We've got multiple y's in the top and the bottom. And we have some factors from the coefficients that we can also cancel out. So notice that 10 and 5 can actually evenly divide. So if I cancel those out and I'm left with 2 up top, so basically I just did 10 divided by 5 to get 2. Similarly, I could do 21 divided by 3 to get 7. So I got a factor of 2 and a factor of 7 up top. Then notice that I can also cancel out the y to the power of 4s, right? Y to the power of 4 divided by y to the power of 4 is going to give us 1, so they'll cancel. And then notice that I have x to the power of 4 on top and then x to the power of 6 on the bottom. Well, the 4 x's up top are going to cancel out with 4 of the x's on the bottom. That's going to leave me with 2 x's on the bottom. And so my final answer is going to be 2 times 7, which is 14, over the x squared that we have at the bottom. So that's the final answer that we would get for that. At this point, you might want to be able to state any restrictions, and if you did want to state some restrictions, you would say that, well, you would notice that x would not be allowed to be equal to 0, so you'd say x is not equal to 0, but also, if you look up top, you're going to notice that if y was equal to 0 in any of the two expressions up there, you would also have an issue, so you'd also have to say, sorry, I forgot the not equal to sign for the x, but you'd also have to say that y is not equal to 0 as well. Okay, that would be the restrictions. All right, let's take a look at a question where you would have to factor first. So let's say we have this question. So a squared plus 2a over 3a times 20a squared over 5a squared plus 10a. So notice that the numerator of the first expression can be factored, and the denominator of the second expression can also be factored. So we're going to start by factoring everything. So really, in every multiplying rational expressions question, you should start by factoring everything wherever possible. Okay, so when we factor the first expression, well, we're going to pull out a factor of a, so we're going to have a times a plus 2, and that's going to be over 3a, which is not really factorable. And when we factor the second expression, we're going to have times 20a squared, which is already factored, and we're going to pull out a common factor of 5a, so we get 5a times a plus 2. Okay, then I'm going to get you guys to notice that we're going to, again, have some canceling going on, actually. Right, so I want you to notice that we have a factor of a plus 2 in the first expression up top and a factor of a plus 2 in the second expression on the bottom. Okay, we also have some a's that we can cancel out. So we got some things that we can kind of cancel out. So we're going to cancel out the 2 a's over there. And then we're going to cancel out the 1a on the bottom of the second expression with one of the 2 a's up top in the second expression. We're also going to cancel out the a plus 2. Now, I know that these are in opposite expressions, but remember that we would typically combine these into one big expression and then cancel them out. And then, of course, we could do 20 divided by 5, which gives us 4 up top. All right? And that's going to leave us with 4a on top and just the 3 on the bottom. So we have 4a divided by 3. And at this point, again, you could state some restrictions. So from we would basically go back to our fully factored expressions, right? So right here, that would suggest that a is not equal to 0, because if it was, then we would have a problem there. We would have the whole denominator equal to 0 there. And also, this here suggests that if a was equal to -2, we would have a problem. So also a is not equal to -2. So those are our restrictions here. Okay? So that's multiplying rational expressions. Take care, guys.